Hello guys and welcome to Freebird's Crew and welcome to 75-day Hard Generative AI Learning Challenge, and this is day 6, and in this video I will tell you about NLP stage 2, in which we will learn about the different type of data preprocessing techniques that are used in natural language processing, and we will also cover every Python code for every technique so that you will understand in theoretically and also in the practical way as well. Okay, so now let me tell you that what actually is data preprocessing. So data preprocessing means we need to change the raw data into the clean data by imputing all the missing values, remove all the noisy data, and along with all the inconsistencies before putting our data into the machine learning model. Okay, so in NLP, data preprocessing techniques take all the raw textual data, okay, and then transform it into the numerical form by some kind of data preprocessing techniques so that it is easy for our algorithms to understand, because every algorithms understand only numerical data. So if we have a textual data, we need to convert it into the numerical form without losing the meaning of it, and we should keep the meaning of it intact. Okay. So now let's talk about the top 7 NLP data preprocessing techniques that are used in NLP along with their Python implementations. Okay, so let's get started. Okay, so our first data preprocessing technique is tokenization. So tokenization in NLP, that means you have a text and you break down that text into its smaller units, which are words or subwords, and the resulting units are called tokens. Okay, and it is the first step. So if you are doing any kind of NLP task, so your first step is to tokenization. Okay, if without tokenization you can't understand the meaning of the text. Okay, because we need tokenization because it helps us to understand the text better. It helps us to extract the features and helps us to extract the meaningful information for our text analysis as well. Okay, so now there are 3 types of tokenization that we use. The first is called word tokenization. The word tokenization means we break the text into word based on the spaces and the punctuations that it used. Okay, for example, if we have the word natural language processing, so its word tokenization means that natural will be different, language would be different, and processing would be different. Okay, and on the same base we have sentence tokenization that split the text into the sentences. So if we have a text corpus of around 15-16 sentences, so it breaks those sentences into each parts. Okay. Now the next thing is subword tokenizations that breaks the word into smaller units, often useful for language with complex morphology, or we can also say that it is the rule-based tokenization, because you set some rules that you want to split the text by this range only, so it will split the text in that range only. Okay. Now there are different type of tokenization techniques as well. The first is rule-based technique, statistical tokenization as well. So we already discussed about the rule-based algorithm, statistical algorithms of NLP in our last video of the day 5. You can learn about those techniques in that video. I will put the link in the description or in the I button. Okay guys, now what are pros and cons of tokenization? Basic pros means it is easy to understand the text by using the tokenization from the various NLP tasks. Tokenization is the first step that we do. And what are the cons? Cons is ambiguity in tokenization for certain languages or context. Okay, it also have the challenges of handling the slangs or abbreviations or domain specific terms. Okay, so these are the basic pros and cons of tokenization. Now let's go to the coding part. So here I install the NLTK library, and from NLTK library I import the word tokenize function, and when I put my sentence into the word tokenize function, it performs the word tokenization. It split my text into the separate words based on the space and the punctuations. Okay, you see that all of the words, all of the small parts are getting separated. Okay, now if we talk about the sentence tokenizations from the sentence tokenize function, it will give me the sentences only. That 2 sentences are there, so 2 sentences are splits here. Okay, now if we talk about the subword tokenizations, so here I set a rule first. I said that I need a word with this range only and from this length. Okay, so this is my rule. I already set that. So it will split the word into this rule only. Okay. Now the next thing is rule-based tokenization, which I already discussed in the previous video. So rule-based tokenization means we have to set some rules by using the regular expression, which I already set here. And based on that rule, it tokenizes the text. Okay, so you see here, it tokenizes the text based on this rule. Okay, now if we talk about the statistical tokenization. Statistical tokenization, commonly referred as sentence boundary detection. Okay, so it is very much similar to the sentence tokenization because it helps to determine the boundaries of a sentence. So where the boundary of a sentence we find, we split the text. Okay, so it can be done by using the PUNKT sentence tokenizer. Okay, you put all your text into this function, then it will tokenize it. Okay. So the next data preprocessing technique is called stemming. So stemming is a text normalization technique used in the natural language processing. It reduces the word to their base or the root form. Okay, so where the word actually started. So if we see this image here, it changed the word changing, change or changed to the chang. Okay, so that means it just make the word to its root node, whether it makes any meaning or not. Okay, so if you see there, the primary objective of the stemming is to map word with similar meanings or the common root, which can simplify the analysis of the data. Okay, and it works by just removing the suffixes from the words. Therefore, it reduces the words to their common base form. Okay, and it is completely intuition based. Okay, so that's why there are like some words which can make the meaning or which cannot make the meaning as well. Okay, so if you see here the word running here, the stemming of the running word would be run. So it makes the meaning. But in the above, it does not make any meaning here. Okay. Now, what are the different types of stemming that we use? The first type of stemming that we use is called Porter stammer. Okay. So the Porter stammer, it just reduces the word to its common form, and it also helps in the dimensionality reduction because reducing the dimensionality of the feature space. Because if we have multiple words, so we can take only one root word from here. We don't need to take all the words that have the similar kind of meaning or context as well. Okay, and what are the cons of it? So it sometimes do the over stemming. As you can see above, it changed the meaning of the changing, change and change. So it is called over stemming here. And what is called understemming, sometimes it is failed to make the word to its base form. Okay, if we just talk about the Python example here from the NLTK library, I just import the Porter stammer, and by using the Porter stammer, I implement it and then see that all my original words are now make into the stemmed word here. Running becomes run, flies become FLI, happily become happily, and better become better, and playing become play. So in that way, some words make meaning and some words don't make any meaning. Okay, so here. And now the next technique, which is kind of the upgraded version of the Porter stammer, it's called snowball stemming. Okay, so it actually a very aggressive kind of stemming because it addresses the limitations and provide a more aggressive way to the Porter stemming. Okay, so while the original Porter stemming was only designed to keep the English in my mind, but the snowball stemming aims to be more language agnostic. It completely provides a framework for creating stemming algorithm for multiple languages as well. Okay, so we just import the snowball stammer here into the English language and apply it on our original words. It also do the same. It also gives us the same kind of word, but in a large corpus of text. These two will surely make a difference as well. Okay, now if we talk about what will you choose? Okay, the choice of the Porter and the snowball stemming completely depend on the requirements and the characteristics of the text data. So if a snowball stemming often preferred for its language agnostic approach and more aggressive stemming, but it may not be always suitable for the every use case because snowball stemming is also quite resource extensive as well. So you need to evaluate the performance of each type of stemming based on your use case as well. Okay guys, okay. Now the next thing is what is called lemmatization. So lemmatization is also a text normalization technique to reduce the words into their base or root form, but it keeps the grammatical meaning of the words. Okay, so in the above stemming we see it does not or does maintain the grammatical meaning, but in lemmatization it maintains the grammatical meaning. Okay, so the base form obtained through lemmatization is called lemma, and unlike stemming, it considers the context and the part of speech of word, resulting in the more accurate transformations. Okay, so how exactly the lemmatization work? So lemmatization often begins with part of speech tagging. Okay, so it first take all the sentence and then tag the part of speech to each word to determine the grammatical category of each word, and then it applies some rules to each part of speech to map the words into their base forms. For example, for verbs like lemmatization may remove the suffixes like ing or ed only. Okay, so it knows the base. It knows that on the basis of part of speech only, it removes those specific words from the actual words. Okay, and it also uses some kind of dictionaries as well to look up for the base form. Okay, but as I can say, lemmatization is doing this much kind of pre-processing, so it is also resource extensive as compared to stemming as well. Okay, so now what are the different types of lemmatization we use? Okay, the first is WordNet lemmatization. It uses the WordNet lexical database to look up for the lemmas, and it is effective for the English language lemmatization. And second is the rule-based. It employs the predefined rules by using the regular expressions, and with the help of that rules, it perform the lemmatization. So if we just import the WordNet lemmatizer here and the tokenizer here as well, because I already told you before performing any kind of NLP task, it's make sure that we tokenize our text. Only then we have to perform other tasks. Okay, so we just first tokenize the text and then perform the lemmatization on each of the word here. Okay, so in that way it just gives us the result. You can see here. Okay, so it makes in that way. The original words are this and the actual words are like this. So it makes the words into word. Okay, and considering context, part of speech, so it just try to reduce the words but keep the form or the context or the grammatical meaning intact. Okay, so now next is what is part of speech tagging. Okay, so we already see the role of part of speech tagging in the lemmatization. So it means that we are assigning the grammatical categories to the words in a sentence based on their syntactic and semantic roles. Okay, so where the word is actually placed in between the sentence, so based on that it assign a kind of a grammatical tags, like what is noun, pronoun, adjective, adverb. So all these kind of things are tagged to each words. Okay, so it just involves analyzing the context of the each word in the sentence, and then it assign the appropriate part of speech tag. Okay, and this is typically done by using the pre-trained models of the rule-based system that is already part of this part of speech tagging function in the NLTK. Okay, so there are very different kind of part of speech tags like noun, verb, adjective, pronoun, preposition, conjunction. So these all would be assigned to your words based on their syntactic and semantic roles. Okay. Now if you see this, we have this kind of a text here, and we first tokenize it and then assign the tags here. And you can see that the tagging means noun, and the else means verbs, in means interjection, and in that way it just apply all the kind of part of speech tag to your words. Okay. So now the next thing is named entity recognition. Okay, so it is the NLP technique that helps to identify and classify the identities such as organizations, peoples, locations, date, and more within the given text. So okay, it plays a more crucial role in extracting the structured information from the unstructured text data. So if we have a very large corpus of data and we want to know what are the like different kind of organizations are in this data, and what kind of locations are mentioned in this data, that can be easily done by using the named entity recognition. So it works in a way that it first tokenizes the text, and then it assigns the part of speech tag to each of the word, and then it identify and classify those token into the predefined categories. There is also a pre-trained model that is already working inside this named entity recognition function inside the NLTK library. Okay, so there are like different types of categories that it can make. We can have person, organization, location, date, time, money, percentage. There are like more categories as well. Okay, so we first do one thing. We first import the Spacy library here, and then it will load the NLP model, and then we have this complete text, and we first apply the named entry recognition here on each of the word by doing the tokenization first. Okay, so this is the tokenization that I do, and by applying the meaning as well, and then we see that it just break down the each word into its specific parts. We know that Apple is a organization, Steve Jobs and Steve Wozniak are the persons, and date, and this is GPE, this is like a location as well. So we see that how it actually works. So in that way, you actually understand the meaning, you actually understand the different kind of parts of your sentences as well to build your more aggressive machine learning models. Okay, so the next thing is stop word removal. Okay, the stop word removal is a complete text preprocessing technique which just remove the common words that do not actually contribute to the significant meaning of your text. Okay, these words which are called stop word, it includes articles, conjunctions, and other like frequently occurring words. Okay, so in our English language, we already have a set of stop words which you can easily find in the NLTK library. We just remove only those stop words from the text. It works in the same way. We have a text, we tokenize it first, and then we remove all the kind of stop word from the text in that way. Okay, so we see here we have a text, we first tokenize it, we get all the stop words, and then we filter out the words, and in that way we just remove all the stop words from the text. Okay, so the next thing is data cleaning and noise removal. Okay, so the data cleaning involves a process of identifying and correcting errors or inconsistencies in the textual data. It involves that we have some irrelevant characters, some kind of a special characters as well. We have some misspelled words, or we have some kind of lower casing or upper casing that we have to do. So that is actually meaning by the data cleaning here. So we first do the remove some special characters from here, then we also correct the meanings of it, and we also do the lowercase transformation as well. So so in that way you can completely clean your text. Okay, now the next thing is noise reduction. So the noise reduction means we remove those irrelevant and distracting information from the text that enhance the signal to noise ratio. Okay, so that means that we have a text and it has some certain characters or abbreviations which do not actually make any kind of meaning. So we need to eliminate those kind of stop words, punctuations, or other things that do not contribute to the meaning of the text. So this here we have the cat is on the mat. So from here we just remove all the punctuations. Only the meaningful is cat or mat. And in this here hello world, we just remove all the this comma and this exclamation as well. So that actually means that we just remove it from there. And it can be done by removing the stop words from the text only. Okay, so this kind of removal and this kind of removal is quietly a part of stop word removal or a data cleaning process only. Okay, so that's it from day 6, and in our day 7 we completely learn about the word embeddings and word to vec model with complete Python code implementation and all the maths behind it. So just be with it, and we'll learn something crazy in the next weeks, because we are on the part of an NLP stage 3. Okay guys, okay, so we'll meet in our next video. So if you want to know more about machine learning algorithms, prompt engineering and generative AI, you can watch my YouTube videos and also watch my blogs on Medium as well. And we'll meet in our next video guys. Thank you so much.